Okay, so here what is given to us is we have to find the distance of point 2, 12, 5 from the point of intersection of the line and the plane, and the equation of line and plane are given to us in vector form. So let us say this kind of figure is what we can imagine. Let us say this is our given plane and there is this line which intersects this plane. I have to find the distance between this point and some another point 2, 12 and 15. So if I get to this point, that if I have this point, then finding the distance between these two will not be very difficult because I can use my distance formula here. So basic difficulty is to get to this point. So now as you can see that P point is nothing but the point of intersection of the plane and the line. So we just have to solve the equation of plane and line to get the value of point P. So the best idea here is to represent any point on the line in terms of lambda, which can be done with this equation. This is the equation of line, which means that any point will have position vector 2 plus 3 lambda I cap. I am just combining I cap, j cap and k cap together. So I will get position vector of any point lying on the line. So this will become 2 plus 3 lambda I cap plus minus 4 plus 4 lambda j cap plus 2 plus 2 lambda k cap. So this is position vector of any point. Now for some value of lambda, it will also represent this point P, which we need, right? But if that is the case, then this position vector should lie on the plane also, if it is the intersection point, which means that this R should now satisfy the equation of plane, right? Okay, so I can write something like this. I can write this R vector in place of this R vector, and on taking dot it will become 2 plus 3 lambda I cap plus minus 4 plus 4 lambda j cap plus 2 plus 2 lambda k cap, taking dot with I cap minus 2 j cap plus k cap is equal to 0. So on taking dot I will get one equation in lambda, which will be 2 plus 3 lambda minus 2 into minus 4 plus 4 lambda plus 1 into 2 plus 2 lambda is equal to 0. If you further try to simplify this, you will get your value of lambda, and value of lambda comes out to be equal to 4. Now this calculation is very easy. If value of lambda is equal to 4, I can reuse or resubstitute the value here. So that will give me what? That will give me the exact position vector of point P, right? So if you substitute lambda is equal to 4 there, so I will get point P as what? Point P will become 14 I cap, then plus 4 j cap plus 10 k cap. This will be the value, right? So when you substitute lambda is equal to 4, you will get position vector of point P, and that will be given by 14 I cap plus 12 j cap plus 10 k cap, right? So now if this is the position vector of P in terms of Cartesian coordinates, I can write the coordinate to be 14, 12, 10, right? So I very well know what is P, and I also know Q, from which I need to calculate the distance. Q is given by 2, 12 and 15. So now I will use distance formula directly to get the distance of PQ line segment. It will be how much? It will be under root of 14 minus 2 whole square plus 12 minus 12 whole square plus 10 minus 5 whole square. 15 whole square, that is 5 whole square, and this becomes 13. So the distance between the 2 points is equal to 13 units.